RAM method for definite integrals. Essential question, can I use RAM to find the definite integral? Can I tell if the approximation is an overestimate or an underestimate? RAM actually stands for rectangular approximation method. If you remember at the beginning of the year, we've approximated area under the curve by counting squares, and we also use the trapezoidal method. Today we're going to take a look at the rectangular approximation method where we approximate with rectangles. Now our first one is called left RAM, and I'll tell you what the L stands for and why we call it left. We are going to try to find the area between 0 and 2, and we're going to do it with 4 partitions, in other words 4 rectangles. So in order to figure out the width of every rectangle, I'm going to find the length of the interval and divide it by how many rectangles, and so that's going to be 0.5. So every 0.5 is the interval, and within this first interval I'm going to use the leftmost x coordinate and use it to help me find my y on my function, and that'll dictate the height of the rectangle, and the width of the rectangle is 0.5. Now I'm going to use the next interval. I'm going to use the leftmost, which is 0.5, and I'm going to find the y coordinate that goes with that x coordinate, and it'll determine the height of the rectangle, and this will be my next rectangle. And I follow that same kind of pattern to find these 4 rectangles, always choosing the leftmost x coordinate on the interval to determine my y coordinate. Now I've done it a little neater on the next slide. Okay, now we're going to actually approximate the area under the curve, so LRAM, and I'm going to use f of 0 to determine my height and times it by 0.5. On the previous screen that was my width, plus the next rectangle will be f of 0.5 times the width 0.5 plus f of 1 times 0.5, and my last rectangle, the height will be f of 1.5 times 0.5. Now each one of them have a 0.5, so I'm going to factor that out, and I'm going to find f of 0. f of 0 is 1. f of 0.5 looks like it's 1.25. f of 1 is 2. And f of 1.5 looks like it's 3.25. So this is going to be 0.5 times, and then this is going to be 7.5, and then I'm going to have to take half of 7.5, and I'm going to get an answer of 3.75. Now the question is this an overestimate or an underestimate? And you can see all the areas right here are actually not, there's some error here, right here. So this is definitely an underestimate because I have these big gaps of area that I haven't accounted for. All right, on right RAM will choose the right-hand side of the interval. So instead of going from the left, I'm doing the right, so it'll be f of 0.5, f of 1, f of 1.5, and so on. And I'm going to go again use the curve to approximate the heights, and I'm going to get approximately 5.75, which is an overestimate because all of this area has been included, which is my error right here. Let's take a look at mid-RAM. That's what the M stands for, mid. So in this interval from 0 to 0.5, I'm going to use actually 0.25 as my x-coordinate to determine my height, which is f of 0.25. And then again, the middle x-coordinate in the interval, 0.75, and then 1.25, and then 1.75. And I find my heights, estimate them as best I can read them, and I get about 4.7. Now, is this an overestimation or an underestimation? And it's kind of hard to tell because we have some area on top and we have some area underneath. So which wins out, the over part or the under? It's hard to tell at this point. Okay, let's go ahead and take a look at trap. And trap we've done before. You can, if you forget the trapezoidal formula, the shortcut that we taught you at the beginning of the year, you can just go through each individual trapezoid. But remember the formula was you times by the width and then times 1/2 of the first y-coordinate, add all the other y-coordinates, and 1/2 of the last one. And we're going to get 4.75 as our answer. And this is an overestimate, and that's because there's just a little bit more area here that we have figured out that really doesn't belong under the curve. All right, let's take a look at a table that's been laid to us and see if we can find all 4 of these using the table. On the next screen, I kind of graphed a little bit just so that you could see. And let's go ahead and take a look at LRAM. Now LRAM is on the left-hand side, so you notice that I have drawn all the heights from the left-hand side, and I get that answer. Now for right RAM in each interval, I guess I'm using the right-hand side of the interval for the x-coordinate to determine my height, the rightmost x-coordinate to determine my height, rightmost x-coordinate to determine my height, and that's the answer I get. Mid-RAM, I'm going to choose this middle, the best that I can, the middle. It's not exactly in the middle, but that's the best we can right here. And I only have one rectangle that I'm going to figure out the area of, and that's 150. And here's the trapezoid rule. Now you can't use that shortcut trapezoid rule because the intervals are not all equal to each other. So I had to find each area of each trapezoid individually and then add them all up. Now let's talk about an actual curve, and you can see on this side I have gone ahead and graphed it. And we would like to estimate the area under the curve with 4 subintervals, and we're going to start with our RAM, or LRAM is what I have here, LRAM. And right here it goes from 0 to 2, just like we have it, and I'm going to increase the number of rectangles. And as you increase the number of rectangles, I want you to notice right here that the estimation is getting better and better and better. And pretty soon the number of rectangles you're seeing, you don't even see the individual, but it's still approximating as we go up. So for left RAM, well, if we want to figure out 4, let me see if I can get to 4. So for 4, left RAM 4, the answer is approximately 3.75. LRAM for 10, let's go ahead and increase that to 10. And that's going to be approximately 4.28, which is a better approximation because I have less and less error. And now let's go to LRAM 50, carry it up to 50. And that's going to be 4.5872. And one more, let's carry it up to 100. Now the more and more rectangles you have, the better and better accuracy. Okay, and then I get 4.6268. So the more rectangles we use, the better the approximation. And this can be done with right endpoints, and it can be done with mid-RAM as well. We're going to be able to give you a calculator program that will allow you to do what we're doing right here on GeoGebra.